Welcome to The Explainer, brought to you on behalf of Forge College. Today, we are undertaking a completely crucial mission for any Web3 developer making the leap. We're translating your EVM code mindsets into SVM realities. If you've been working with Solidity, your brain is just wired a certain way, right? Well, today, our goal is to completely rewire it, mapping out a totally new architectural blueprint so you can really understand the structural constraints of Rust and Anchor.
Okay, let's dive right into this, and honestly, we just have to rip the Band-Aid off right away. Solidity makes it incredibly easy, almost too easy, to rely on implicit mapping rules. Everything just nests nicely in the contract storage. But leaving that comfort zone means abandoning implicit state entirely. In the Solana and Anchor ecosystem, explicit constraints are going to be your new best friends. Here is our blueprint for today. 1. Core primitives. 2. The 3 mental models. 3. A concrete ERC20 translation. And 4. A quick recap and next steps. Let's get to it. Section 1. Core primitives. Identifying what needs translating. Before we can translate anything, we really have to isolate our foundational token elements. Solidity gives us this cozy world of implicit storage, logic embedded right in the code, and just endless nested mappings. Anchor, on the other hand, demands explicit accounts, incredibly strict structural constraints, and a complete separation of your data from its enforcement surface. And this just brilliantly illustrates that moving to Solana isn't just a logic rewrite, it is a fundamental architectural translation.
Now, what's really interesting about this schematic is that it acts as our Rosetta Stone. Think about a basic total supply scaler. That becomes a mint state account, usually sized as a U64 or U128. Your balances mapping, that turns into either a custom per-holder PDA or an SPL-associated token account. And those tricky nested allowances mappings that we all use, they become completely isolated allowance PDAs. Even the simple owner address check transforms into rigorous signer or PDA constraints. It's a whole new paradigm.
Moving on to Section 2, the 3 mental models. This is your translation checklist. To make this translation repeatable, and honestly, a lot less overwhelming, we need a reliable system. So the first mental model is state as owned containers. In Ethereum, a mapping is just a logical key-value store. On Solana, every single piece of persistent state is a container that must be owned by a program, and crucially, funded with rent-exempt lamports. You generally have 3 choices for that container: a monolithic account containing a serialized map, a spread of small per-key accounts, or just delegating the whole thing to the SBL token program's accounts.
The second model is authority versus signature. In Solidity, you lean heavily on MSG.sender and quick modifiers, right? Solana, conversely, maps authorization to explicit signers and program-derived addresses, or PDAs. I actually like to think of PDAs as capability-carrying lockers. They can be used to cryptographically assert that the program legitimately controls a resource, which completely bypasses the need for an external wallet signature. The third model focuses on serialization boundaries. Look, Solidity lets you dynamically resize nested structs on the cheap. Solana absolutely does not. Account sizes are fixed right at creation. Imagine each account is packing a really rigid suitcase for a notoriously cheap airline flight. If you go over the pre-measured limit, you are going to pay a hefty price, or you simply won't fly. So you must avoid dynamic resizing, use fixed widths like U64, and park large metadata strings into separate accounts entirely. Okay, let's take a quick breath. We've talked theory, we've talked strict containers and rigid suitcases. But how does this actually apply when you sit down to code? Let's pause and ask the big question. How does a standard ERC20 actually look when forced through these exact mental models into Anchor? Which brings us to Section 3, ERC20 to Anchor, a concrete translation. First up on the drawing board, total supply. The classic EVM uint26 total supply translates in Anchor to a mint state struct stored in a program-owned global PDA. And notice we've actually swapped down to a U64 here. Why? Because matching the SPL token program's standard 64-bit integer width is almost always your best bet for compatibility. That is, unless you're dealing with absolutely massive specialized token scales that strictly demand a UN28. Let's move to the balances mapping and see how this builds out. In Solidity, this is just an easy ledger inside the contract. But in Anchor, you face a major design trade-off. You could create custom balance account PDAs for every single token holder. This gives you amazing customizability, sure, but you are going to be paying network rent for every single one of those accounts. The alternative? Offload all of that math, all the logic, and the rent management to the SPL token program by using associated token accounts. And now for the true horror of EVM translations, nested mappings. The allowances mapping in Solidity, where an owner maps to a spender who then maps to an amount, is an absolute nightmare to dynamically resize in Solana. It requires expensive account reallocation. So instead, we break it out. We engineer an isolated, highly specific allowance PDA. Because it's isolated, it is beautifully simple to revoke or close when the allowance hits 0, which frees up all those precious imports.
So the absolutely crucial point here is managing your account size and ensuring data safety. Look at these rules for metadata. You must separate your metadata into small, dedicated PDAs. If you have large strings, push them to off-chain URIs so you don't inflate your on-chain rent costs. And from a strict safety perspective, always include a U8 version tag at the start of your serialized state, paired with size validation. This ensures that when you eventually upgrade your program, old clients fail fast instead of causing some catastrophic deserialization bug.
Finally, Section 4, Recap and Next Steps, wrapping up the blueprint. We've covered a tremendous amount of ground today, literally pulling apart EVM logic and meticulously reassembling it under SVM constraints. So, here are your 5 golden takeaways to ensure you're fully prepped for actual REST coding. 1. Map everything to explicit accounts, whether that's monolithic, per key, or SPL. 2. Your authority is now an explicit signer or a PDA. Just completely forget message sender. 3. Isolate your metadata and allowances to master your rent control. 4. Be super consistent with your U64 or U128 integer widths. And 5. Always protect your data by including versioning in your serialized state. Which brings us to the ultimate question. Are your layouts truly ready for Anchor? Think about that Solidity contract you've been working on recently. Can you visualize its rigid, rent-exempt containers right now? Hold on to that thought as you prepare to write out your account macros. Thank you so much for joining me on this explainer. To master the rest of this transition journey and really dive deep into the code, make sure you visit forge.college. I'll see you next time.